Okay, so big picture. Today, this is day 2 of parametrics. Then we just, basically, after I've covered this stuff, we've pretty much covered everything you're gonna learn. And then we'll take a little quiz on it tomorrow in class. And then some of you that may need to take that test from Friday, still haven't taken it yet, tomorrow will be your day in class, because we'll take that quiz, pretty much all we'll do, and then grade that quiz in class. Then on Thursday, we have a review, and then Friday's the test. So what is parametrics? It's a different graphing system, and we just got off of a unit called Polar, and in Polar we had to convert things. You remember Polar where it was like r equals 5, and we were like, how do you convert that into parametric? And then you'd square both sides, and then you'd say r squared is 25, and then r squared is really x squared plus y squared. Okay, and that converted Polar to rectangular. Well, we're going to do the same thing here today. We're going to have to understand how we can convert these, which are like x equals 2t. Everybody write this down, please. Y equals t squared. If that's a parametric system, it's missing something vital. What's got to be in all the parametric systems? Less than equal to, keep going. X. Close.
Or T.
There you go. Keep going.
And then less than equal to 2.
Good. So that rounds it out. That is called I call it a limiter. Okay? We want to limit this. It doesn't just go forever. Now what's special is it's got 3 variables. So if you track this thing, you have t and x and y. At any time, you have an x and you have a y value. Just to make sure you get this, would you please put in the -1 for t and see what you get? And then let's go all the way to the end. We'll 1, 2, skip a few, and then put in 2 and see what you get. So get the values once you stick in t as -1 and 2. I'm going to pause for a second. We'll try that. Okay. What'd you get, Callie, when you stuck in -1?
-2.
And, all right. Davis, when you stuck in 2?
I got 4 for x and 4 for y.
Excellent. All right. Now, let's just graph this real quick. I want to remind you how to graph something that has 3 parts to it. So one part you don't really graph, you just write it on the graph. So Charlie, can you explain, how do I graph this first point, for example, right here?
You go to -2 for x and then 1 for y.
-2 and 1, there's a dot. Okay, now what?
Then you write t is -1.
Good. And then let's do the other point, 4, 4. Over 4, up 4. And that spot is at t equals 2. And then I'm drawing a line. I'm assuming a straight line. Is that logical assumption? No, it's not. All right, so we would need some more points in between there, and it's very likely this is curving. And if you had to guess, does it feel like this should be a parabola, like a U shape? I agree. All right, so then let's just say that we make a couple more points. It wouldn't be that hard to get the real ones, but let's say it goes something like that. Now, don't forget it has arrows along the way, but not on the tip. Why doesn't it have an arrow on the tip? Because it doesn't keep going. It stops at time 2. The end does not go past 2. All right. Okay, you guys get the idea there? Okay, now, what if I ask you to convert it? So I want to get this to be without the t's anymore. So the first one you just solve for t. Everybody just write down what t equals. For this one right here, solve it for t. Ava, what's t equal to? Yep. And then don't solve the other one for t. There's an easier way. When it's squared like this, it's easier to just take this And t is x over 2, right? So we're replacing the t with x over 2. And look, there's no more t. Get what happened there? Y equals x over 2 quantity squared. You don't always have to solve them both. If you want to get rid of the t, you just have to find a creative way to get rid of the t. Question?
So what if x equals t squared, and then we do plus or minus for x, or
I can't do what ifs like that. Sure, if there was a different problem, we'd have to solve it a different way. Okay, so I just can't, I don't want to go through all the what if scenarios for you. When we hit different problems, we'll have to solve them different ways. So this kind, we could get t alone really easy. So then we just go plunk that in where the other t was. And yeah, if it was different, we'd have to do it differently. All right, so now that got us this equation. Y equals x over t over 2 quantity squared. But do you feel like something missing? What's missing? Yes. Yes, that limiter. Can I just like say, well, you don't have a t anymore, so I'll just call it x? Yes, except you can't use the same numbers. Okay, so what did it used to be? It used to be from -1 to 2, but that's not, this is x, this is different. So now we go to our chart, and we say our x goes from -2 to 4. That is a rectangular or non-parametric equation. All right. Then there was another kind, and that was x equals cosine theta, y equals sine theta. Now, if I just write this, if I just had this, do you get that this is not parametric? Why isn't it parametric? There's no t, and what else? There's no limit. Normally we have a limit on parametrics that goes from this to that. Even if we'd say the limit is no limits, which is like saying t is between -infinity and +infinity, there's usually a limit, and there's usually a t. All right, so then let's put a t in here. Let's put a t in here. All right, so now I'm wrong. We're not going to put it there. That'd be too hard. We're going to put the t here. Because theta is a variable, right? So now we've got x and y and t, and we just put our t in where our angle was. Now, I'm going to say that I want this to go from pi over 2 to pi. So there's the problem they give you, and they say this is parametric. One thing they could ask you to do, graph it. So everybody start by making a TXY chart. And by now, I hope I've convinced you to learn how to do circuitry, because if you don't know how to do pi over 2 and pi, you're going to have a really hard time finding this one. Because we just decided to make t pi over 2. And then figure out the rest of this point right here. I put in pi over 2, see what I get. If you're going to draw cosine of pi over 2, hopefully your skills on pi over 2 are strong enough to know that that is that spot right there. And then you're not drawing a triangle for that kind. Sammy, what's the spot right there?
0, 1.
Excellent. And then we go cosine of that is what?
0.
And the sine of that? Excellent. So at pi over 2, we got 0 and 1. All right. Charlie, can you tell me what point I'm going to put in next for my dxy chart here?
Pi over 4.
I'm going between pi over 2
Oh,
and pi.
sorry.
Would you agree that pi is here?
Yeah.
So I like the idea that you want to find something else before that, because we probably should have, if we just have 2 points, we don't know where the curve is. So can you name me something else, some other angle that would be in here?
Pi over 3.
1/3 of a pi is only here.
Uh,
This is where pi over 2 is. This is where pi is. What's something between those two?
2 pi over 3.
2 pi over 3s would absolutely work. That's like here-ish. 2 pi over 3. So let's use 2 pi over 3. Now I got the beginnings of a triangle right there. And I have to do sine and cosine of it. So I better like put in some sides on it. Marcus, give me some sides that would be on this thing.
360. So the hypotenuse would be 2.
Okay. And is this 1, 2, and square root of 3? Is that how this goes? It's close.
Flip the
If this is a pi over 3, therefore this is a 60. So I don't have to flip anything. Across from the 60 is the square root of 3, but what I have to do is make this negative. I got it right now? Okay, so if I'm going to do cosine in that triangle, cosine of this angle, cosine of 2 pi over 3, it's somewhere between these two. So I just picked one thing in there. Okay, so 2 pi over 3, cosine of that is adjacent over hypotenuse, negative 1/2. Sine of that, opposite of hypotenuse, root 3 over 2. I totally understand that you don't know exactly where root 3 over 2 is. That's like about 1.5 over 2. It's a decimal. It's less than 2 over 2, right? So it's less than 1. And this is negative 1/2. Anybody can graph that. All right, and we need one last point, which is the ending point, which is pi. So if I'm going to do pi, Davis, you get the lucky call. How do I do pi? Well, pi is over here. What point do I put here to help me find cosine and sine of it?
Negative 1, comma 0.
Negative 1, comma 0. And then cosine of pi
Negative 1,
and sine of pi.
0.
Now, everybody graph those 3 points. 0, 1. Negative 1/2, comma, some decimal I'm not sure of. And then negative 1, comma 0. Root 3 over 2. Well, it's definitely not 2 over 2, which would be 1. So it's a little less. So it's negative 1/2, means I go over about here, and then I go up. Some decimal, like maybe right there. And look at that, it's making part of a circle. I hope you kind of like knew that was going to happen. Look at me putting an arrow on it and doing it wrong. It's just slight, but what did I do slightly wrong, Sam? Sam L? My arrow, something's wrong with it.
Can you not have
Not on the end. Know why? Because it stops right there. See there, it stops. It doesn't go past pi. So they should not have an arrow at the end. But I can have arrows in the middle. 1 or 2 arrows, either way is fine. Cool, we graphed it. That's about as hard as they get because it involves circle trig and parametrics. And now I'm going to go back to this one last time. X equals cosine theta, y equals sine theta, and t is between pi over 2 and pi. That was a good, difficult, oh, and I replaced the thetas with t's because this is supposed to have x's and y's and t's. There we go. There was my problem. Now, do you know how, maybe somebody looked at the key last night, how you could convert this over to parametric? There's different strategies for each one. Sorry, it's parametric. Convert it to rectangular. Yes?
This isn't perfect, but if you do x equals inverse cosine of the t.
You're trying to get t alone, I understand that, so you're going to go, t would be inverse cosine of x.
Yeah.
Is that what you mean?
Mm-hmm.
Okay.
And you do the same for y.
Okay.
Then set them equal to each other.
All right, so let's try that. T equals inverse sine. I don't know if this is going to work or not, but it's worth a try. Okay, keep going.
And then you can set them equal to each other.
Since t is this and t is that, we can say,
Inverse sine of y, that
thank you. Inverse sine of y is equal to inverse cosine of x.
is. And then to get rid of the inverse sine of the y, we can just do the sine of the inverse sine of x.
So you're going to do sine of this, but you can't just do it on one side.
You do it on both sides.
Okay. So then we will have sine of inverse cosine of x. It actually might work.
Just when you graph it, inverse cosine has a different range. So you've already got the top half.
Yeah, it's going to get really crazy. All right, so let me show you another way, because that is cool, but it is going to make it much more complicated than what you'll see, what the rectangular can be. And I know that I wouldn't expect a kid to come up with this solution, but I expect you to be able to follow it. Okay, so would you agree that we can square both sides if we want to? Does that make sense to you guys? I can square this both sides on both of them. And does anybody look at that and go, oh, x squared plus y squared, I've seen that before. Okay, so what allows me to just add those together like that and say x squared plus y squared? Let me just show you something like this. 2x plus y equals 12, and x minus y equals 14. Did you know that you can add those straight down and say 3x equals 26? If you didn't know that you could add like this in equations, let me explain why you can. If I want to add 14 to this side, that's cool, as long as we add 14 to the other side. But that's equal to 14. So I can add 14 on the one side and x plus minus y on the other side. That's why you can add straight down in equations. So look, I'm going to add straight down. I'm going to add y squared on this side, and since this is equal to y squared, right, because it says so, I'm going to add y squared to both sides, but this one's just going to be a sine squared because it's equal to y squared. So then I can add these straight down and say cosine squared plus sine squared. And you know what's cool about that? Somebody drag this up out of your memory banks. Madeline.
Cosine squared plus sine squared equals 1.
It equals 1. And look at how clean that is. And that is rectangular. Okay. Now I have 2 more things that I have to teach you today, and then you've pretty much learned everything. So the next thing is really easy. Everybody graph the point 1, comma 2. And then graph the point 5, comma 4. Now I know you've heard of a line segment, but have you ever heard of a directed line segment? Just to clarify, this is not the same as a ray. Do you guys remember a ray from geometry with an arrow on the end? Okay, this is not the same as that. Now why? Because this one has a direction, but it stops. Stops right there. Doesn't go past that. But it has a direction. So, how is this related to parametrics? Well, parametrics are good at having a beginning and an end. And so you can make a parametric for this. You can make an x equation and a y equation and a limiter for t. Now with just that hint, I think somebody can do it. I think without even my help, I think somebody can write this equation for the parametric that goes between 1, comma 2 and then goes to 5, comma 4. Let's see if anybody can do it. I'm going to pause for a minute. If you can't, it's okay. This is like creating your own math without the book teaching you. But I'll show you how in a sec. All right. She says, I'm going to just rearrange it. 1 plus 4t. And the other one you said was 2 plus 2t. All right. Now, how can I know if she's right? One more thing you got to know is, do you have the limit right? So what's your limiter?
Between 0 and 1.
0 to 1. All right. Now, let's see if she got that right. Now, how could I know? What do you always do to start? You have forgotten. This is really important. TXY. Everybody make a TXY. We're just going to prove she's either right or wrong. And I'll show you how to do this in a second. But if I put in t as 0, then that'll zero out both this part and that part, and it'll leave behind this part right here and that part. And 1, comma 2 would be the results. It looks like it's working. Okay, and then what am I going to put in for the other end? T equals 1 for the other end. And then if I put in a 1, it goes there, and then I get 4 plus 1 is 5. And then this, when I put a 1 there, it's 2 plus 2 is 4. Look at that. It starts at 1, 2, and ends at 5, 4. Perfect. Now, see those 2 blue spots? That was the original point. The starting point. So that's what you do. You put your starting point right there. And then you say, how much did it change? You went from 1 to 5. That's going up 4 for each t. And of course, we have to have a t in it, right? Otherwise, it's not parametric. And then this 2 goes up to 4, and that increased by 2. We needed a t. And then how do you do this part? I got a really simple answer for you. Always go between 0 and 1. If you're going to do it the way I just showed you, always go between 0 and 1. Nice job. You created new math. Would you get that right too? Do you have the same? They have a different solution. Okay, just to clarify, there is more than one way to do it. And there is more than one right answer for a parametric. Now, how could I judge yours to be right or wrong? I'd make a TXY for yours, and yours better come up with a 1, comma 2 and a 5, comma 4. And if it does, then we'd know yours is right too. Did it work?
Yeah.
All right. So, frankly though, I don't want to confuse people because we're late into the lesson here. I'm happy that you found another way to do it, and it is okay. The way I would check yours, if I think you're, like you didn't give the answer everybody else does, I would check and see that your TXY chart would give the right starting point and the right ending point. And if it does, then I'd say it's cool. Because see, you don't have to pick 0 to 1. You could have picked like 1 to 2. And then your numbers would be different for your T's. The numbers on the T's would be different. Yes?
Is it possible that you could do, like, you could write the equation for the initial one, and then you could substitute T for Y, and then say T equals Y?
I get what you're saying, and there's something like that. Just let me teach the last thing, and then I think you'll see that what you just said ties in really well to the last thing that I need to teach you. Okay, but just to make sure you guys really understood that, let's get a point 1 comma 5 going to 3 comma negative 5. You don't need to graph it. I just need a parametric, which means an x and a y and a t limit. Can you write me a correct equation that goes between these two? I'd do it the way I just showed you. Mira actually is the one who just showed you. Pause for a second while you give that one a shot. This is the first of the new things. It's called a directed line segment because it has a starting and an ending spot, and we have a direction. It goes from the one point to the other point. You don't have to graph it. That wouldn't be hard. It'd be super easy to graph, but what you have to do is write the equation for it. How many of you are done? Raise your hand if you're done already. Okay, I'm gonna pause for a second. In case you forgot, you take this point and you start with that. And then you see what the change was. How much did it go up from 1 to 3? And from 5 to negative 5. I'll pause for a second. Give you more time to try that. Okay, so x equals, well, this first thing you do is you just take this and you put it here, and the y is 5, 1 and 5. And then you got to go, I would just always do plus just to start with. And then I'm going to call this the change times t. Triangle is the shortcut name for change. Okay, so change, what was the change? Well, the change went from 1 to 3, so that's a change of 2. There we go. The other one was a change from 5 to negative 5, and that's going down 10. So plus negative 10t. Now, do you really need a plus and a minus? I wouldn't mark it wrong. It's not illegal because you have just a system and you always put plus there, but plus minus does actually mean just minus. There we go. And now I need my t limiter. It kind of got scrunched for space, so I'm going to move it over here. Always go between 0 and 1 if you're doing it this way. And then always check yourself before you wreck yourself. Iced tea.
Ice cube.
Thank you, ice cube. Thank you. Dang it, not iced tea. Ice cube. All right, TXY chart. So the t is going to be 0, and I make sure it actually worked. If I put in a 0 here and here, that's the magic of this. You get the 1 and the 5 to come out. And that's what I wanted. Started at 1, 5. And then if I put in a 1 here, because I'm only doing one set of 2 that's getting added on, then I get 3. And then I put a 1 here, and that's 5 minus 10, which makes negative 5. And look at that. That is that. So I did it right. That is called a parametric equation for a directed line segment. Feel like you could do that one? I hope those feel fairly easy. All right, then last thing. We've converted from parametric to rectangular. What if you have a rectangular and you want it converted to parametric? Would you agree this is a line? Just graph it quick. Just make a quick little sketch of it. Should be reminded every now and then how to graph these things. It's surprising how hard it is to like get your mind back into simple algebra mode sometimes. 2x plus 7, so then there must be a 7 here. And 2x means a slope of 2. You get how it goes forever like that? All right. What if I didn't want it to go forever like that? What if I wanted it to start here and then just go up? Do you get that would be saying, kind of like on a parametric, that I want to have a limit on this? From, well, this spot would be right here, would be 7. So that would be 0, comma 7 to infinity. So my x limit could be said to be from 7 to infinity. Nope, not x is 7. Sorry, this would actually be y, a y limit. Y is between 7 and infinity. Couldn't I have said it x is between 0 and infinity? Process that. All right, so I'm making it more complicated than it has to be. Let's just start with, I see some eyes glossing over. Let's just start with this. That goes forever in both directions. I can make parametrics that go forever. I just have to have the t has to have no limit. Okay, so let's just start with that. All right, so how do I do it? Well, you need an x equation and you need a y equation. And I think you have an idea. What do you think?
Can you like set both sides equal to t?
Okay, so in the end, I just want to have an x equals equation and a y equals equation, and they both have to have a t in it. So can you tell me one?
Y equals t.
Maybe. Okay, and then what are you going to do for the x?
X equals.
You're so close. Here, just move it the other way. Make x equal to t.
X equals t, y equals 2t plus 7.
There it is. Now look at what he did. I want you to process what he did. He pretty much just took that y equals equation and wrote it again, except he changed the x to t. And then above it, he said x is t. So if t is x, then I can just put an x right where the t is, y equals 2x plus 7. So it worked. Nice job. But I did say you have to have a limit, so finish it.
Negative infinity is less than or equal to t.
Although you can't actually be infinity, so just being picky, but it's a negative infinity.
Oh yeah. Is less than infinity.
Yep. That is the right answer. Don't overthink this. You just take the equation, you solve it for y, and you got your y equals equation. Except you put a t there instead of x, and then you set x equal to t. There's other ways to do it again. How would I judge if it's right? Well, I'd make a whole bunch of points, and if my points end up falling right on this line, then I know I'm doing it right. And they would. So again, this is here is just here, except the x is a t, and then you say x is t. And then since this one doesn't have any limit, I could go from negative infinity to positive infinity. Now, maybe that's what I'm realizing now. I should start with that. And then I should go, but what if I wanted to start right there? And then I wanted to go forever in that direction. Then all of a sudden I got to have a limit. And our x is pretty much like t. I mean, it says x is t, right? So what's our x limited to? What's the smallest x can be? And therefore, what's the smallest t can be? 0. There it is. smallest x can be. Because I decided I wanted it to start right there at x is 0. Yes, it's also y is something, but my y can't be my limiter because x is t. And t's there to be the limiter. All right, so here's one last one. Y equals 9x. Done, that's it. Can you change that equation into parametric? Henry, what's something I have to make a parametric? You gotta have limits, very good. But on parametrics, the limit is about the t. So I'm gonna say my t has to have limits like that, okay? Audrey, tell me something else I have to have for parametric.
I said TXY chart.
You're right, I can't ever argue with that. To check your answer, you should have a TXY chart, but before that, I would need to have an equation. Sammy, give me one of the two equations, and how do I know there's two equations?
Are you setting x to t? Or?
We need an x and a y equation. Would you agree with that?
Yes.
Okay. So then let's start with y.
So y is 9x.
9x. But what would be wrong with that? Every x and y equation has to have a t. So therefore, now you tell me, if I have to have a t, wouldn't that be the logical place to put it? And then what's x equal to?
Y over 9.
Overthinking it. I just had
Oh, t.
an x right there, and I changed it to t because x equals t. There. And what's my t between? Did this one have any limit? No. If that didn't have any limit, then t doesn't have any limit. Negative infinity to infinity. What if I had said, I only want to start at the point 0, 0 and go forever? Then how would you change it?
You change the negative infinity to 0 and the less than between it to less than or equal to.
Ooh, very good, because it can be at 0, 0 and then it goes forever. Okay, you have now learned everything. Now tomorrow you get a quiz. I'm going to pause for a second while I look and see what our homework looks like for today. Okay, here we are. Everybody find this spot to practice for the quiz that you're going to have tomorrow. I'm going to strongly recommend that you do number 5. And how do you always start? TXY. I've said it at least 3 times, maybe 4 today. So you got to get used to that. That's how you start. And what's t? Well, it says less than or equal to 1, so I'm going to pick 1. And it says less than or equal to 1, so then I'm going to go down to 0. And then I'm going to do negative 1. So I'm going to at least want 3 points. Why? Because it's a curve. And I might want to keep going. All right. Next kind. You should do one that has sine and cosine in it for sure. Something that we're going to test you on. I don't know that we need to do both. Let's just do this one. Doesn't mean you shouldn't do that. Depends. If you really struggle on 19, then you should try 20 after you look at the key. Wait till I'm done going through what problems you should do. Next, on this page, I'd like you to just do these 2. Skip the last one. I know there might be others at the bottom of the page. We're not doing anything except the ones I'm showing you. All right. So, those will be good practice for the quiz, which happens tomorrow. This parametrics quiz is only gonna count as homework. It is not gonna count as a test. It's gonna ask you to graph some. It's gonna ask you to change some from polar to rectangular. It's not polar, sorry. Parametric to rectangular. And yeah, that'll happen tomorrow in class. Now, if there's anybody that has missed the test from Friday and wants to make it up tomorrow as your day in class, you could also do it in the morning before school. Wednesday mornings are always good for math time. Also, after this, tomorrow we have another morning help day. So, question?
So on the yellow page, how would we convert that to like a equation?
All right, so I think that's enough for our video for today. Have a great day.